Hi everyone, we're going to start Module 11 today, and our main topic for Module 11 is angles. Now before we talk about angles, there's one other vocab word I want to teach you guys. So in Module 10 we learned about a line, which goes forever in two directions, and we learned about a line segment which stops on both ends. If you have one of each, it's called a ray. So if you have something where on one side it looks like a line signal, like you have this point where it starts, but on the other side it's got that arrow to show that it keeps going forever, that's what we call a ray. Or the way I described it in the notes, it's kind of like half a line. Now the reason that word is important for us today, we're going to use it to define angle. An angle is two rays that start at the same point, like this picture here. So what we have is two different rays, each one in blue, I called it ray 1, and in red, ray 2. But what's important is that they both start at the same point. That purple point is called the vertex of the angle. And because you have two rays that start at that point, that's basically what makes an angle. Those three things together make an angle. All right, so let's learn our naming conventions. Ever since we started talking about geometry, I told you guys one of the real important things about geometry is understanding the notations and the naming conventions, so you know how to talk about different things. And I'm going to say, let's start with this picture right here. If I give you a picture of an angle, and I look at it and there's kind of only one angle I could be talking about, if that's the case, you can just tell me the letter of the vertex to be the name of the angle. So for example, in this picture right here, I could call it angle A. And then also kind of mixed in with that, what that means, this symbol right here, which is a little angle, that's the symbol for angle. So I could actually say it in words like I typed in quotes, angle A, or more commonly, if I want to talk about angle A in a problem, I'm just going to do this thing right here. Now the reason I can call this angle A is because number one, the vertex is A. And number two, there's only one angle in the picture I could possibly be talking about. Now, here's when you can't just call it angle A. So let's say I had a picture like this. So right here we have two lines crossing. I marked 5 points, A, B, C, D, and E. So there's kind of a lot of different angles in this picture. So in this picture right here, if I just said angle E, you wouldn't know what I was talking about. I might be talking about this angle right here. Or maybe I'm talking about this angle up here on top. Or no, maybe I'm talking about this angle over here. You guys can see there's actually 4 different ones. Or maybe I'm talking about this angle down here on the bottom. All of those, all 4 of those, blue, green, red, and purple, have E for the vertex. So if I just said angle E for this picture, you wouldn't know which one I meant. And that's why usually when we're talking about an angle, instead of just using one letter for the vertex, we use 3 points, 3 letters to name the angle. So basically what you want is one point that's on one of the 2 rays, then the vertex, then one point from the other ray. So it kind of goes in order, like you're going in the order that you would draw the angle. Now, it's very important to remember the vertex is always the middle letter, no matter what. The vertex, if I give you an angle of 3 letters, if I call it A, B, C, then B is the vertex. If I tell you angle P, Q, R, then Q is the vertex. Whatever that middle letter is will always be the vertex. So let's go back to our first picture. I said I could call this angle A if I want. Here are two other names. I could call this one angle A, because again, it's the only angle I could be talking about. But these 2 names here are better. I could call it angle BAC, because it goes from B to A to C. It's like you're going in order to draw the angle, BAC, or you can go the other direction. I can call it CAB. So I could start here at C and go this way to A, and then this way up to B. So it kind of depends on how you're drawing it, but you're going in order of how you would draw it. You would go BAC or CAB. Now, ABC is not this angle. So it's important to remember the order does matter. You can't just throw the letters. A lot of people will go, okay, I see 3 points, A, B, and C. I'm going to put them in alphabetical order and just call this angle ABC. Well, what you would actually be talking about, I'll draw that angle for you. If you said angle ABC, you mean you're starting down here somewhere. You're going through angle A to point B, and then from point B down here this way. Actually, I kind of missed there. Through point C. But you get the idea. That purple angle is angle ABC. It's not the one that was originally in the picture. So when you're naming angles, 3 points is best. Go in order in either direction, but make sure the vertex is the middle letter. Now, another way, sometimes in problems when there's a whole bunch of angles in the picture and it can be confusing, a book might number them, or we could number them. So in this picture here below, let's say I wanted to talk about, I'll highlight one of them in red here. Let's say I wanted to talk about this angle right here in red. So I said I could call it angle ABC, that's the direction I drew it, from point A to B to C. Or, because they were numbered, I could just call it angle 1. And that would mean the same thing. I could also call it angle CBA if I went those letters backwards. I didn't type that into the notes, but that would work too. I can't call it angle B because there's 4 different angles there I might mean, so you can't just use one letter there. But I could call it ABC or CBA, or what would be easiest, I just call it angle 1 because it's numbered. So you can number the angles too, or if they are numbered for you in a problem, just use those for the name. All right, let me give you guys some more vocabulary. So number 1, we don't usually think of a line as an angle, but technically it is. So a line is sometimes called a straight angle or opposite rays, because if you think about it, if I drew a ray, let's say I drew this ray right here, point on one end, going forever on the other end. Well, if I did an opposite ray, meaning I'm going to draw another ray, but starting at the same point but going in the exact opposite direction, then what you've done is you've created a line. You've just put arrows on both ends. So 2 rays going in the opposite direction, or opposite rays, create a line. Now technically, even though we don't usually think of that as an angle, it is. It's 180 degrees. If I measure this angle right here would be 180 degrees. So we can call a line a straight angle or opposite rays, and it equals 180 degrees. Now a right angle, like you find in a square or a rectangle, that perfect 90-degree angle, is half of that. If I took that straight angle and split it exactly in half like that, 180 divided by 2 is 90. So I'm basically cutting it into those perfect square angles, and each one is a right angle or 90 degrees. Now finally, here's a word we've already used in Module 10. It applies to angles also. We used it for line segments. We said the word congruent means exactly the same. It's just like equal, but it's for shapes instead of numbers. So whereas you might say x equals 5 in an equation, if you're trying to say that 2 angles are exactly the same, we say they're congruent. And the way we're going to show them on a picture, so remember when we did line segments, we showed things were congruent by putting the little markers on them? We're going to show angles are congruent using arcs. And I'll show you how to do that. All right, so let's take a look at several different angles. Maybe we have one angle right here, and maybe we have another angle over here. Maybe over here we have those lines crossing that create several different angles. So I've created a whole bunch of angles here. Now let's say I wanted to show that 2 angles were congruent. Like maybe this one over here was congruent to this one right here. And I'm actually going to take those arrow marks out. So what I could do, if I wanted to show that those angles were equal, what I could do is I could put a little, this is called an arc right here. If I put a little mark right here, that means those 2 are congruent. They're the same. Now let's say, remember how when we did line segments, 1 was congruent to 1, 2 was congruent to 2, and it kept going? Let's say I have 2 more congruent angles. Then I'll just do 2 markers. So maybe 1, 2 is congruent to 1, 2. And then maybe you even have a third congruent angle somewhere. Maybe it's right here. 1, 2, 3, congruent to 1, 2, 3. And I can keep going. I can do 4 and then 5 and then 6, however many you need. So each marker matches up. One marker matches up with 1. Those are congruent. 2 with 2, 3 with 3. And you can have more than one. Like maybe I put a 1 marker right here too. Now I have 3 different congruent angles. 1, 2, 3. Those are all congruent. But then the 2s are congruent and the 3s are congruent. So you guys get how it works. You use what we call arcs to mark congruent angles. However many pairs or sets of congruent angles, just keep adding an arc. All right. So another thing that we talked about during Module 10 on line segments was a bisector. Bisecting works for angles too. So remember, to bisect something means to cut exactly in half. So in Module 10, we had a line segment. We bisected it. It cut it into 2 equal pieces. Right here, we have an angle. If we bisect that, it cuts it into 2 equal pieces. So in this picture right here, line segment OC, that's the red line segment there, bisects angle AOB, which is the black angle, or dark blue, whatever color that is. Now what I did, or what this picture does, I didn't actually create this picture, but they gave you an arc. They actually put markers on the arc. You can do that, you don't have to. They did kind of our combination of our 2 notations. By marking this arc and this arc here congruent, then you know that OC, line segment OC, was a bisector. It cut it exactly in half. So just like line segments, if you have a bisector, it will cut an angle exactly in half or into 2 congruent pieces. So what I would say is angle AOC, remember follow the letters in order, is congruent to angle COB. AOC would be the top angle, like right here, I'll number it number 1, and COB would be number 2 there. So let's put it all together and let's do an example. So in this picture, what we have, there's several angles in this picture actually. The biggest angle that you see is PRS, from P here to R to S, PRS. Then you have that line segment, or that ray actually, RQ in the middle. And because of these red markers here, because of this arc here and this arc here, you know that RQ is a bisector of PRS, and you know that those things are equal. So when I'm setting up my equation, it's going to be this thing right here, x plus 40, equals this thing right here, 3x minus 20. Let's set that equation up. X plus 40 equals 3x minus 20. And I'm going to solve for x. I'm going to put in that dotted line I like to do sometimes, just to remind myself anything I do on one side of the line I have to do on both. And I have an x on both sides. Let's get rid of one of them. This x over here on the left, remember an x by itself is really 1x, even though you don't see it there. Let's get rid of that by subtracting it. Let's subtract 1x from both sides. That leaves just the 40 over here. 3x minus 1x is 2x, and it does leave the minus 20 over here. So then to finish solving for x, the next thing I would want to do is get rid of that minus 20, and to do that I'm going to use a plus 20. Cancels that out. 40 plus 20 is 60, leaves just 2x over here. And the last thing I want to cancel is the 2, and I can do that by dividing both sides by 2. So what I get is x equals 30. Now remember what I told you in class. Don't box it up and move on to the next question. In a question like this, always go back and check the directions. If I had said solve for x, that's the answer. I didn't say solve for x. I said find the measure of angle PRS. Now PRS, that's the big angle, the whole thing. So what I would probably do now for the next step is take that answer, x equals 30, pick one of the two angles, it actually doesn't matter which one, and substitute 30 for x. So if I wanted to find angle PRQ, not the answer to the question, but that angle up top, if I substitute 30 for that x, I get 30 plus 40, which is 70. So this angle right here is 70 degrees. Now remember, they're equal. So this angle right here is also 70 degrees. And you can figure that out by plugging x in there too, but you don't need to. If you plug in 30 for x, 3 times 30 is 90. 90 minus 20 is 70. But you didn't need to do that. You already knew they were equal. So if they're both 70, then by adding them up, basically, you get 70 plus 70 is 140. So the final answer to the question, which you remember, was angle PRS. That's the whole thing. It's not each little one. The final answer to the question is 140 degrees. So that had to do with recognizing you have congruent angles. Congruent angles, their measures are always going to be equal. So you set those two expressions equal, you solve for x. When you get x, you use it and make sure you're answering the right question. Always make sure you're answering the right question. A lot of times people just get x equals 30, they put a box around it, they go, good, I did my work and I'm done. They move on and they miss a few points on that. So always make sure you're answering the right question.